Let's start the lesson with chapter 5, 5.1, squares and square roots. The basic expression for all squares and square roots is m, n, whereas m is a value and n is the number of m in a multiplication. The first thing we need to remember is squares. This expression was m squares. For example, we have 4 multiplied by 4 is 16. Or you can say that 4 squares is 16. This equation shows that 4 multiplies by itself once to get 16. It's very simple. Second thing that we need to know is square root. You don't need to remember the radical function or the radical symbol here. You just need to remember that which number multiplies by itself to have the number inside the symbol. For example, we have 16 divided by 4 to have 4, which means that 4 multiplied by 4 to have 16. Or you can say that 4 is the square root of 16. Squares of 0 would be 0, just because 0 multiplied by itself equal to 0. In fact, positive numbers have 2 square roots and negative numbers don't have any. For example, we have 4 again, multiplied by itself once to have 16. Or we can have a negative integers like -4 multiplied by itself once to get 16. And why the negative numbers don't have any square root? Just because 16 minus 16 is equal to -4 multiplied by 4. -4 is very different from 4, which is 1 is smaller than 0 and 4 is higher than 0. This thing here is the function machine that we have to know about squares and square root. It's very simple. Minus m multiplied by minus m, or m multiplied by m, is equal to m squares, which is also equal to radical m squares and minus radical m squares. This worksheet here should be finally well attached to the one who need that for practice. Okay.
We'll move to cube and cube roots. First is cube. A cube of a number is formed when you multiply a number by itself and then itself again. We have some examples like 6 times 6 times 6 equal 6 cubes equal 216, or 9 times 9 times 9 equal 9 cubes equal to 729. Another way to describe 6 is the cube root of 216. The cube root is not so different to square root, except that it has the cube root of a negative number. We can use the symbol on the screen to describe it, and we have some examples. You can see it. Thank you. And down here we have some little quizzes to some weak person. Thank you.
So, as we've learned in the previous lessons, the power or the exponent of a number tells us how many times to use a number in a multiplication. Or in other words, it means how many times a number is multiplied by itself. So for example, 2 times 2 times 2 times 2 times 2 equals 32, or 2 to the 5th power. So we say that 32 is a power of 2. You can work out the other powers of 2 or any other numbers by trying different bases with different exponents. For example, these are the examples. For each of them, there are corresponding roots. For example, 2 to the 4th power equals 16, and so the 4th root of 16 equals 2. 3 to the 4th power equals 81, and so the 4th power of 81 equals 3. And here are some examples of powers and roots. Below are some quizzes and like worksheet that you can try to. Thank you.
Nextly, we will move on to exponential decay. So what is exponential decay? Exponential decay is the population or group of something is that declining, and the amount that decreases is proportional to the size of the population. Exponential also represent continuous growth and decay, but in this case, it shows decay. Down here is some equations. For exponential, the equation is y equal ab to the power of x. But for especially only for exponential decay, it is y equal to a times 1 minus r all to the power of x. And in here, a is the initial value, r is the decay rate, and x is the number of time intervals that have passed. And also the domain for these equations are a must be larger than 0 and b must be smaller than 0. This is a graph showing exponential decay. And also there are some examples. And so the graph here shows y equal 10 times 0.5 to the power of x. And as it is an exponential decay, so the slope, it goes down to the right. And nextly, we have an example. So in this example, we start with 160 pieces of candy, and as it decreases by a half each day, we have a following equation of y equal 160 times 1.5 to the power x. And finally, there's a graph showing the equation, and that's all. Down here, we also have some examples, exercise to people to revise if you want.